Hey guys, welcome. Today we'll be talking about how to create annotation for YOLO. Let's say we have these images of dogs and cat and we need to annotate. So here we have two classes, one is dog and one is cat. First, collect the data that you want to annotate. Then go to Google and type YOLOv10 pip and then click on this link. So it will show this website and copy this command, this pip install YOLOv10. Then go to your terminal and create a new environment for your project. So conda create an new environment, data annotation, Python. I'm using 3.8. You can use a specific version or you can use the latest version of Python to create this environment. Now hit enter. It will download the required files and it will create the environment. Now it is downloading. Yep. Okay, environment is created. Now active the environment. Conda activate data underscore anno. Then paste the command that you have copied from here into here. Pip install YOLOv10. So it has collected the packages and it has installed YOLOv10. Now type YOLOv10. And this is the application we'll be using for annotation. Open directory, go to the directory where you have saved your data, that is here, and select that folder. You can see the other images we have here, and then select change save directory and choose the same folder. So basically we're saying like, okay, keep the annotation file here also. So this is the software, and here we have two classes, one is dog and one is cat. So to annotate that, make sure that this is selected as YOLO. We have bunch of format here, but make sure this is selected as YOLO. That means YOLO is activated here. Then go here and display labels. If it is unchecked, check these labels. So it will show the labels after bounding boxes, and then create rectangle box. So this is dog. Create the rectangle box as close to as possible to the object and give the name dog. So this is our first class we are creating here, and then on the keyboard you can hit W, so it will start another bounding box. Now select here, so this is also dog, and then select cat here. So this is our cat here, and this is our cat. So this is our first image we have annotated. Save this thing. After saving, you will get a text file like this. So if you compare this thing with the value we have, this shows like we have two classes, that is class 0 for dog and class 1 for cat, and we have 4 objects here. You can see 1 2 3 4, and these are the bounding boxes for these 4 objects. And if you open this folder, you will get another text file, that is this is classes.txt. and if you compare this with this text file, you can see 0 means this index. That means the class 0 is assigned to class dog, and class 1, this index is assigned to class cat. So let's say you have more than 2 classes. All the classes will be listed here, and the indexing will be starting from 0. So if you have like, let's say, horse or elephant, their classes will be 2 and 3, because we have already 0 and 1 here. So classes will be listed in this txt file, and their index will be starting from 0. So if we talk about the values here, you can see the first value that represents class ID. You can see this is dog here. The second value that represents the x value of centroid. So this is the center of the bounding box, you can see here. The third value, that is y value, that is y coordinate of the centroid, you can see here. The fourth value is the width of the bounding box, and the fifth one is height of the bounding box, you can see. So this is the format of YOLO annotation. Okay, so this is how to do the annotation. Now let's go to the second picture. So this is the second picture. Hit W on your keyboard and then select the cat here. This is a cat, and then dog. So you can see dog is up to this point, so it is like it is taking some portion of the cat also, but fine, we have to annotate like that only. So cover the entire object, doesn't matter if it is overlapping or not, but you have to cover the entire object. Now this is stop, so this is save now. Okay, now go to the next image. Here select the dog. Now you can see the dog, and this is the cat. Hit save and go to the next picture. Here this is dog, and this is the cat. Here this is the cat because its paw is here, and because this is the dog. Now we have completed our annotation, you can see. And if you go to the folder, we have annotation files corresponding to each image. And this is your dataset now for YOLO training. Hey guys, welcome. Today we'll be talking about how to train YOLOv10 on a custom dataset. YOLOv10 is the latest model in YOLO series, and it is released recently. If you check this graph, you can see YOLOv10 has lower latency as compared to other detection models, and you can see it has the greater accuracy as compared to others. If you check this graph, you can see the number of parameters for YOLOv10 is smaller as compared to other models. That means for training it will take less amount of time, it will take less resources such as RAMs and GPUs. Now if you want to check GitHub repo, you can go to this link, and this is the official GitHub repo of YOLOv10. You can see they have built YOLOv10 on Ultralytics framework, so you can use Ultralytic commands just like we have seen in case of YOLOv8 to do training, to do validation, to do testing. And if you want to check the research paper, this is the link to research paper. You can download the research paper from here, and you can go to the research paper if you want. Now for our project, we'll be using this dataset. I have given the link here, also I'll give the link in description of this video. So this dataset contains an aerial image of a roundabout, you can see, and here we have 5 number of classes. We have car, cycle, bus, truck and van. So download the dataset from here, then upload everything to your Google Drive. So I would suggest please maintain this folder structure, so it will be easier to follow this code. So here I have uploaded everything to this folder. You can see we have both images and their respective annotation files. Then in this folder we'll be having output from our inferencing on both images and videos. And then this test folder, here we have a bunch of images on which we'll be doing our testing after training the model. Now after that we have training backup. This folder will be created during training, and you will have all these things after the training is completed. Then in this folder we have videos on which we'll be doing our inferencing after we have the model from training. So here I'm importing everything, all the required libraries that we want for this training process. Then here here we have Tesla T4. Then here you can do pip install Ultralytics. It will take some time to do to install Ultralytics and all the requirements that are needed for this process. Then here if you do run this, you will get this message, that means installation of Ultralytics is successful. Then here after that, so guys, I'm not running all these commands because it will take some time to do all these installations, and I have already done this. So we'll move further just like this. You can follow the process, you'll get similar kind of result, and it will be easier for you to run this notebook to in order to train your own V10 model. Now here we are connecting to our Google Drive to get the data that we want for training. Here you can do this, then this, continue, and then OK. Now it's trying to connect with the Google Drive. You can see here. Okay, so our Google Drive is mounted here, and if you click here, you can see we have Drive here. Then here we are just giving the path where we'll be storing our training images, our validation images, and testing images. Now if you run these two functions, they will try to read the data from this folder, and then they will create the train and val folder, and also they will create the dataset.yaml file. You can see here the process has started. So you can see after this process we have a total number of 976 images, out of which we have 781 images in training folder and 195 images in validation folder. So if you go to this folder, you can see we have training and validation folder. Then we have this dataset.yaml. So here you can see we have directory to our training folder and then directory to our validation folder. Then we have class information that we have in our dataset. After that, you can run this command to install all requirements that are needed for YOLOv10. Then you can download the weights from here. So if you go to the GitHub link, you can see we have all these weights that are pre-trained on Coco dataset, and we can use any weight out of all these weight to fine-tune this YOLOv10 model. So if you want to download these weights, you can use these commands. So these are basically, this is YOLOv10 small, this is medium and large. Now after that, here we are doing the training, and you can see here we have task equal to detection, because this is a detection model that we want to train. Now here the mode is train, and then model we are giving the path to our YOLOv10 large model that we have inside this folder. And then here we have data. Here we are giving the path to our dataset.yaml file that we have created earlier, you can see. Then here we are training the model for 15 number of epochs, image size is 640, batch size is 8. Then project, here we are giving the directory where the model will store all the necessary file, and that will be generated during training. And here the name is traffic2. That means within this folder it will create another folder traffic2, and within that it will store all necessary files. So if you go to our Google Drive, you can see this is the folder, this training backup, and then within that we have traffic2, you can see, and then within traffic2 all the necessary files that will be generated during training will be stored. And here within this folder we have something called weights, and within weights everything will be stored. So guys, I have deleted the weight files that were generated during training. I just kept last weight and best weight here. And then here we have optimizers, that is Adam. And when you run this command, you will get information like this from your terminal. That means the training has started. I can see I've trained the model for 15 number of epochs, and after that it will do the validation and it will show all these metrics after the training is completed. Let's understand how to do inferencing using this trained model on both images and videos. Remember, we have images within this folder. You can see within this folder. So I have given that folder directory to this source parameter, and then here we are using the best weight that was generated during training, and then we are using a confidence threshold that is 0.55, and we are inferencing on these images. When you run this command, you will get messages like this. After this, we are using this command to copy all these results from this runs detect predict directory to our Google Drive. So if you run this command, you will get all the images within this folder. And if you open this image, you can see this is the detection that we have from our model, from our YOLOv10 large model, after training it for 50 number of epochs. You can see detection are pretty good. So we have a bunch of objects here. Still we are getting detections, like you can see the threshold is greater than 80, so this is nice. And here we have some missing detection. You can see this is the truck, but our model is unable to catch this. So guys, we train the model only for 50 number of epochs, and if you want to get a better model, you need to train the model for more number of epochs, and you need to play with the hyperparameters that can control the behavior of the model. Now if you want to run inferencing on videos, same thing. You can give the path to the videos on which you want to do inferencing, and if you run this command, you will get messages like this. That means inferencing has started on the video. And then if you run this command, similarly you will copy the output results, the output video from this inferencing process to your Google Drive. And if you do that, you will have output like this. Let's play this one. So you can see the model is getting a little bit confused around here, and there are some detections which are missing. It's fine because this is the behavior that we can get from the model after training it for 50 number of epochs only. Let's play this one. Okay, so this is a little bit stable as compared to the previous one. So guys, we have completed the tutorial on how to train YOLOv10 on a custom dataset. I hope you understood the process, and I'm sure you'll be using this YOLOv10 in your project. Today we'll be talking about road traffic analysis. But why? Why do we need to do this road traffic analysis? What is the application of this project? From this road traffic analysis project, we can do a better transportation planning. We can find out road capacity. We can do traffic signal optimization. We can find a better way to do congestion management. Now, if you want to learn more about this traffic analysis, this existing data collection system, you can visit all these websites. You'll get a good understanding of this traffic analysis, and why do we need this? Why do we need to integrate AI in this traffic analysis system? I'll give this link in the description. Now here in our project, this will be our input image. When we run our code, our output will look like this. So you can see we are printing out the counts at these critical locations. You can see this is position 2, this is position 1, this is position 3, and this is position 4. And here if you look at each object, you can see we are printing out the bounding box, the class ID, the tracking ID, and the speed of that particular object. Now here the pipeline will look like this. We'll give the image to YOLO. It will give us the bounding box and the class information. Then we'll pass this bounding box to OC tracker. It will generate ID, and from these tracked objects we'll be doing our counting, we'll be doing our speed estimation, we'll be plotting trails, we'll be plotting heat map also. So if you come here, you can see this will be our input video. You can see just a plain simple aerial view of this roundabout traffic. And when we do process, we'll be creating all these outputs. So here you can see this is the output that we have been talking about. You can see all this counting here. We are operating the counting here also. The RY is blinking when an object crosses. That means the RY color changes to white. You can see here. And then we have this output. Each dot represents an object, and the color changes with respect to the speed. You can see like red color means the object are not moving, and you can see the different color represents different speed. Then we have this output. So here we have split the entire frame into 40 by 40 grids. So basically we have created like this. We have split the entire frame into this number of grids. Then we are estimating the average speed within each grid, and then we are putting color based on that average speed information. So red means you can see like here the object speed are like 0 to 20. You can see 0 to 20, and then yellow means 40 to 60. Slightly orange means 20 to 40, and then 60 to 80 means green, and 80 plus represented by blue. So then we have this output. You can see we have the original output video. Then here we are plotting the trails of each object. In this analysis, we can identify the area where the traffic is higher, where the congestion is higher, so that will be more focused on those areas during planning our transportation system. Now we have this video also. This is just plotting the trails, you can see here. And then we have this final analysis video. So here we have everything. We have the output video, we have the trail video, we have the speed dots video, you can see, and we have speed heat map video. So for each object we are drawing center of the box, the bounding box, then class name, you can see the tracking ID and speed. So in this project we are using YOLO for object detection, we are using OC for tracking. So here this is the GitHub of YOLOv10, and this is the GitHub of OC. So guys, you can switch OC with any of these trackers. Now if you want to learn how to train YOLOv10, we have created a video earlier. You can follow this video. We have described everything. So here for this project we have already trained our model, and we have a YOLOv10 weight, and we'll be using that weight for this project. Now let's check our code. So this is the code that we'll be using for our project. You can see it has everything, and it will create all those output videos. So here first we are importing all these required libraries, then we are importing YOLO, we are importing OC, you can see here, and then here we are giving the path to input video, we are specifying the output folder. Then here you can see we are specifying path to all the output videos we have seen earlier. And then here we are checking like whether GPU is available or not. Then here we are loading the YOLOv10 model. You can see we are specifying the confidence threshold, that is 0.75. then here we are initializing the tracker, you can see. And here we are creating a bunch of variables and a bunch of functions which will be useful in our project. Here we are defining different colors for different classes that we have in our model. Then here we are selecting the color for this different positions. Remember, we have different color for different positions, so we are defining here. Then here we are specifying a particular area for a particular position. So for example, if you look at here, the logic will be, you can see objects will be moving from left to right. That means when an object crosses this RY, it should get counted. But here if you look at here, this entire thing will have the same X value. For this position, we don't have to worry about this area and this area. That's why we are specifying an area, you can see. And here the condition will be if the object enters into this area, and then if the object crosses this RY of that area, you can see, then it will be counted for this position. Similarly, if an object enters into this area and if it crosses this RY, it will get counted for this position. That's why we have selected all these coordinates. Then here this is calculating the RY. That means this is calculating the location of this RY lines which will be using for counting. Now this function is responsible for detection and this function is responsible for tracking. Let's do one thing, guys. Let's understand all these functions one by one from here. So basically, when we run this script, it will load everything and then it will start from here. It will start executing from here. First, it will execute this function, and you can see we have defined all this path and all this variable in the beginning of the script. You can see here. Now let's check this function. So this will be this function. You can see we are giving all this input to this function. Then here it is loading the video, you can see. Then here it is extracting crucial information such as width of the frame, height of the frame, FPS information. Then here we are creating multiple video writers because we are creating multiple outputs from our input video. We have seen this earlier. Then here we are creating a canvas. So guys, you can see this will be our original frame, and this, you can see, these canvases or these frames are created from this original frame. So the size of these frames, you can see, is similar to this frame. So we are creating that canvas here. Then here we are creating bunch of variables to keep track of information like cross object, counted object, blinking state, blinking frame. So this blink state and blink frame, you can see, guys, when an object crosses on a ROI, the color changes to white and then it changes back to the original color. So these two variables here, you can see, we are creating to perform this mechanism. Now here we have last position to keep track of last position of objects, and then here we are keeping track of object speed. And now here we have started reading the video frame by frame. Now here we are using this function to create this image. So this is nothing but the plotting of grid information on the frame. In this way we can visualize like whether we are creating correct grids or not. So basically here each grid size is 40 by 40 pixel, you can see. So each grid size is of 40 by 40 pixel, and then it is plotting information like it is plotting this represents y value, this blue line represents x values. You can see like all these 12. So this grid will be 12 and 4, and this will be 12 and 12. Similarly, this will be you can see 13 and 31. So after that, here we have plotted that information to make sure that we are creating the good grids. Then here we are doing our detection. So here we are passing the frame to this function. You can see within that we are passing the frame to our model. It is giving some results, and then from these results we are extracting bounding box information. You can see x1, y1, x2, y2. We have confidence information, the confidence probability from our detection, and then we have class information, and then we are returning all these values. Now after the detection, we are passing those values to our tracked objects. So this tracked object function, it will pass these detections to our tracker, and it will update our tracker. Now by doing this, our tracker will be able to keep track of all the detections that we are getting from our model. Now after that, here detection is done, then we have tracked objects, so tracking is done here. Now we have a bunch of objects with unique IDs. Now after that, here we are drawing this blinking count RY information. So basically this function is responsible for that blinking effect that we have seen earlier. You can see here it is using blink state. If blink state we have a true value, it will turn into white, otherwise it will give the original color. Now using that, it is plotting the white line or the line with the original color on the frame. Now after that, okay, here, so this is done. After that, here we are looping through all the tracked objects. You can see we are extracting bounding box coordinates here, then we are calculating centered x and centered y. Then here we are plotting the bounding box and the centroid of each object. You can see. Then here we are estimating the speed, and then we are saving the previous location also. If you go to this function, you can see this is like finding the Euclidean distance. Here it is converting distance in pixels into meters. Then here you can see it is calculating the speed. Then it is converting speed in meter per second to kilometer per hour. Let's understand the speed calculation in this way. So we know speed is equal to distance by final time minus initial time. So let's think that we have this road, we have this car, and the distance between these two RYs is 100 pixels. So when the car is at this location, we have like t1 equal to 0. Then when the car is at this location, you can see we have t2 equal to 20 seconds. So 1 meter, here we are considering like 1 meter is represented by 10 pixels. Hence 1 pixel is 1 by 10 meter. So speed is equal to 100 by 20 minus 0. You can see using this equation. Now here we have 5 pixel per second. The speed is 5 pixel per second. Now if we convert that into meter per second, we have 5 into 1 by 10. You can see we have 0.5 meter per second. And if you want to convert this meter per second into kilometer per hour, we have to do like this. Now this speed, this 5 pixel per second, is now 1.8 kilometer per hour. This calculation is represented by this function. Now after that, here, okay, so we are done with this speed estimation. We have speed of this object. Now you can see here we are performing the counting. So remember, we have discussed the object should be within this area, then it should cross this particular RY to be counted for this position. So same thing is happening here. So here first we are checking whether the object is within this area or not, and if yes, then whether we are checking the direction. Here you can see we are checking the direction, because for this RY the direction would be top to bottom, for this thing the direction would be right to left, and this thing the direction would be bottom to top, and for this thing the direction would be left to right. So here we are checking the direction, and according to that we are determining whether the object has crossed or not. And if the object has crossed and it hasn't counted yet, we are counting the object, then we are updating the relevant information, and then here we are selecting blinking state, that is true, and blinking frame, that is FPS. Now you must be thinking, why FPS and why all this calculation? So let's check an example. Let's an object crosses position 1 at frame 100 and the video is of 30 FPS. So at frame 100 the blinking state position is set to true. This is true, and then blink frame position is set to 30. You can see this is FPS. So for frame 101 to 129 the position 1 will be drawn in white, and after that the blink frame will be 0, you can see, and then blink state will be false. That means after this the color of this RY line will be turned back to the original color, just like this. When you can see, when the object crosses it is white, and then it return to the original color. After that, here we are putting all this count information on the top left corner of our frame. You can see all this information here. Then here, then draw counts near RY. So this function is creating this counts. You can see for each RY it is showing the counts also. You can see counts 18. So this function is doing that. It is extracting the relevant information, the position information, and the critical RY information, and then it is putting the count information near to that RY. You can see. After that, here we are creating this speed.analysis, this frame or this video. So this function is receiving all this information. It is looping through all the tracked objects. You can see it is finding the speed of each object, and then it is selecting color based upon the speed, and then it is plotting the circles and the information based upon these requirements. So that function is creating this video. Now after that, after creating the speed dot information, the speed dot visualization, we are creating visualize speed area map. So basically this function is responsible for creating this video. You can see it is creating the grids here. You can see, then it is looping through all the tracked objects. It is finding out the grid information, and it is finding out the speed information also. So basically what it is doing, let's say we have a frame of 1280 and 720 pixels, which gives us a 32 by 18 grids. So basically if we divide this pixel with a grid size of 40 by 40, we'll get 32 into 18 number of grids. And let's say we have an object which will be having this bounding box. You can see here. Now from this bounding box we can calculate the centroid, and that will be 180 by 220. So by doing this, you can see, so by doing this we can find out at which grid location this object is currently at. That means if here for this object For this object, the grid location will be 4 and 5. That means this is grid location 1 2 3 4. This is x value and this is 5. So the object would be at this grid, and then using that information we are increasing the count and we are increasing the speed. Now here we have defined a preset colors for a speed limit. For example, if the speed is between 0 to 20, use red. If the speed is between 20 to 40, use orange, and then for 40 to 60, yellow, 60 to 80, green, and 80 plus, use blue. So basically you can see when we have blue color, that means the car is traveling at a speed of more than 80 km per hour. If we have red color, you can see that these cars, they are stopped here, or their speed is less than 20 km per hour. And this color defined, you can see like this is between 20 to 40 and this is between 40 to 60. So we have defined these values for that. Now here you can see we are looping through the grid size, then we are finding out the speed, the average speed of each grid, and then we're changing the color for that grid based on this average speed. And then here we're just plotting all this count information here, RY, all this legend information. You can see this legend information on the frame. Now after that, so we are done with this visualization speed area, and we're done with this creating speed dots. Now here just we're plotting all this blinking count ROI. We're plotting counts near ROI on different videos, you can see. Then here we are creating the trail video. You can see this is the trail video. Now this video is created by this function. You can see here it is looping through all these tracked objects. It is extracting the boundary marks information. It is calculating the centroid here. Then it is appending the centroid information to the existing trail information. Then here it is drawing the trail, you can see. Now okay, so we have learned how to create all these separate videos and which function is responsible for which video. Now after that, I think we are done here. So after that, here we are just writing all these separate videos using the video writer we have created earlier. Then we are creating this combined frame using this function. So here we have frames and then height and width, all these things. And then here you can see we are resizing everything and we are stacking all the frames together to create this combined output. After that, we are writing the combined output to a master video. Then here we are releasing all the video writers we have created earlier. This is the whole code for this project. In the previous episode, we have learned how to create this project. In today's episode, we'll be learning how to Dockerize this project. Now, you must be thinking, what is a Docker? Let's understand Docker in this way. So this is our project. Now, if I ask you to build this project, what will you do? So here you can see the talented coder with a Linux system. To build this project, you will first create the environment. To create this environment, you will be using Anaconda, PyTorch, Ultralytics and YOLO. Then you will be installing all these libraries which are required. After that, you will be working with the Python code. Now, let's think that you have a team of people working on the same project. So here, this is you with the Linux system, and you follow the documentation of all these libraries that are related to Linux installation. Now let's say your friend has iOS system. Now he has to work on the same project. Now here he has to follow the installation guide for the iOS. You can see all the packages, all the libraries are same, but installation will be different. Similarly, if you have multiple people with multiple OS systems, they have to follow the respective installation guide for all these libraries to create the required environment. Let's say it will take 1 hour to create this environment. So in this team, the total number of hours that will be spent to build this environment will be 1, 2, 3, 4, 5. Let's say a new teammate joins this team to work on this project. He or she has to go through the same process of installation to create this environment. There might be some cases where certain libraries are available for Linux but are not available for iOS or Windows system. There might be some cases where a particular version which is required for this project is not available for either Linux or Windows or iOS. So in this scenario, it will create conflict, it will create issues to create the environment, hence it will create issues for your project. Now let's say you have completed everything and you have gone through all these issues, you have solved all these issues and you have created your project. So after creating your project, your priority is for deployment. So now you have your project and you have the instruction how to set up the environment for this project. Now what we'll do, you will give this project to the operation team. Now the operation team will take these files or this project from you and they will go to the deployment side and they will follow your instruction to set up the environment so that they can deploy the product. Here there might be some cases where there is a miscommunication between you and the operation team because they did not develop this app. You developed this app or you developed this project, hence you know all the issues, hence you know how to install everything correctly. But there could be some miscommunication between this file that you created for the installation and the operation team, hence they won't be able to create the environment and installation process will throw the error. Now here you will be thinking like, okay, they can contact you and you can solve this error and the installation process will be completed. But here you are thinking about only one project site, only one deployment site. What happens when you have multiple sites and you have multiple errors? All these sites will have different error and they will contact you to solve all this error so that they can deploy the project perfectly. But remember, in case of deployment, you need to work fast and you need to solve all this error as soon as possible. Can you imagine? This will be a very painful process. To solve all these issues during development and deployment process, we have Docker. In case of Docker, you created the Docker file, you installed all the libraries to create the environment inside Docker, and now you created the app. Now you are working with the app, the Python file that is needed. So here your friends or your colleagues, they don't have to install all these libraries in their system to create the environment. They'll just install Docker, they'll just set up Docker and they can use the same Docker file you created and they can work on the same project. Similarly, in case of deployment, you will give the Docker file to your operation team and they will deploy the Docker file at the development site. Here also, they don't have to install all these libraries one by one following your instruction. They just have to set up the Docker environment. Also, during development, you will be coordinating with the operation team to set up this Docker. Hence, there won't be any issues in case of deployment. So Docker helped us solving all these critical issues. Now, if we talk about the definition of Docker, it is like Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so that you can deliver software quickly. With Docker, you can manage your infrastructure in the same ways you can manage your application. So guys, I got this definition from the official Docker documentation. Guys, you can explore this documentation. You can learn about how to build Docker, how to work with Docker, how to do networking inside Docker, and all those stuff. Also, I would suggest go to watch this tutorial. This tutorial is Docker tutorial for beginner. This is like Tech Wall with Nana. She created this video. It's a very good explanation on Docker creation, Docker running, and all those stuff. Now let's build our own Docker. So here, this is our file structure. You can see here we have all the codes that we created for our project inside this folder. Then we have this model widget folder. Here we have the train model that we use in our product, in our project. Then we have output folder. So the outputs will be stored inside this folder. Then we have videos folder. Here these are the input videos on which we can run our inferencing. Then we have this kitignore file. Then we have this ppt, and we have this docker compose, docker file, and requirement.txt. So we'll be using these three to build our Docker image, and then we can use that image to create our container. So basically here you can see we have this folder structure, and inside this folder we have all our scripts. What we'll do, we'll copy all these scripts inside Docker. We'll copy the requirement file inside Docker, and then using this requirement file and this Docker compose and Docker file, we'll be setting up the environment inside Docker. Now if you check the code, you can see this is the Docker file and this is the Docker compose file. So we'll be using this Docker compose file to create our image, to create our container, and to manage our containers. So here you can see this is the Docker compose version. Then here we're creating our containers. You can see, so this container PyTraffic we are building from this Docker file. And if you look at this Docker file, here we are saying that we are creating this Docker from the base image, that is PyTorch 2.1.2. Then we're installing all this library that are required for OpenCV. Then we're installing pip, git, wget, curl, fmpeg libraries, and all those packages. After that, we are creating this traffic YOLO folder. Remember, so here we are creating this traffic YOLO folder or directory, and after that we are copying the requirement.txt. Then we are copying the PyScripts folder. You can see PyScript folder here, all this content from the PyScript folder. Then we are installing all the libraries that are mentioned in the requirement.txt file. So if we see the requirement.txt, you can see these are the libraries that are needed for our project. So here we are installing all these libraries. After that, here we are setting up YOLOv10 in this environment. So we have copied everything here, and then we have created the environment. We have installed everything that are needed for our project. After that, you can see here, so we have set up the Docker image here. Then here we have given the name of this Docker image, that is traffic YOLO. This is version 1.0, and then we have a container name, that is traffic X. Then here we are setting up volumes. That means these folders will be mapped to this folder inside Docker. So basically this is our local directory and this is our Docker. So here we are mapping this folder with this folder, this output with this output, and videos with videos. So everything that we have inside this folder, Docker can access. And after that, here we are setting up to access the GPU while running any container. Then we are saying that this is our working directory, this traffic YOLO folder, and from this directory we are running the command, that is python main.py. So basically here we have this main.py folder, py file, and we are executing this Python file. So we'll be working with all these commands. So docker compose build, this will create the Docker image. Docker compose off, it will create and run a Docker container from this image. Then docker compose down, it will remove all the Docker container that we created earlier. Then docker images, it will show all the created images. Then docker ps-a, it will show all created containers. Then docker log, this is the container id. Then docker remove docker rm this id, so we are removing this particular container. And then docker rmi this thing, so here we are removing the image, which id is this. Let's see all these commands in action. So guys, we have learned how to Dockerize our project. I hope this was helpful. Please like, subscribe and share. I'll see you in the next video. Till then, take care.